Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be looking at calculations using the mole involving compounds. Now if you haven't watched our previous video on calculations using the mole involving atoms, you really need to check out that video before coming here, because the concept here is not going to make sense. The concepts here are not going to make sense if you don't know the concepts from the previous videos. So it's almost like, especially in chemistry, we see this pattern of things kind of adding up, and you knowing something previous, and that you need to know that in order to learn something else. And this is especially very true in stoichiometry. Every video in this unit, you're going to need to know everything before you come and jump into any video. This is not the type of unit where you can just watch any video and just understand it. So go and make sure you watch the previous videos in this unit before you come and watch this video. Okay, so hopefully you've done that. Now let's talk about calculations using the mole involving compounds. Okay, so here is a question. We have 1.00 moles of CH4, or 6.022 times 10 to the 23rd molecules of CH4. So this is a difference. And when we talked about atoms, we said 1 mole of atoms is 6.022 times 10 to the 23rd atoms. So when you talk about moles of a compound, it's 6.022 times 10 to the 23rd molecules of that compound. Okay, so here we have the question is asking us 1 mole of CH4 has a mass of. So if you think about it, if you think about this, if you look at 1 mole of CH4, technically this can be thought of as 1 mole of carbon and then 4 moles of hydrogen. Okay? Because think about it, if you have 1 mole of CH4, you have 1 mole of carbon atoms and 4 moles of hydrogen from the 4 here. Okay? Just like how if you had 1 molecule of CH4, you have 1 molecule of carbon and 4 molecules of hydrogen. Just like in the same way, if you have 1 mole of CH4, you have 1 mole of carbon and 4 moles of hydrogen. So if you wanted to find what 1 mole of CH4, what the mass would be, you can do this. So you can just find the mass of 1 mole of carbon and then the mass of 4 moles of hydrogen, add them together, and then you get the mass of 1 mole of CH4. Okay, so really what you're doing here is you're breaking it on your elements. You're breaking it down to its elements. So we know 1 mole of carbon. If you look at the periodic table, the molar mass of carbon, the average atomic mass of carbon is 12.01 U. So 1 mole of carbon is going to have 12.01 grams. And then 4 moles of hydrogen. 1 mole of hydrogen, the average atomic mass, if you look on the periodic table, I don't want to go and look and zoom because that's just going to waste time, but I'm just going to tell you, the average atomic mass of hydrogen is 1.008. So 4 moles of that is going to be 4.032 grams. And then you can just add this number to this number to get the total mass, so 12.01 plus 4.032. And that's going to equal a total of 16.042. So 1 mole of CH4 is going to have 16.042 grams. So just to recap, what we do is we break it down to its elements, and we find the mass of each element, and then we add together like this, in this method we did here, in order to get this number. Also, another important term, I didn't define this in the previous video, but it's going to be important here, that you need to know is the term molar mass. So molar mass of a element or a compound is just what the mass of that substance would be, 1 mole of that substance. What would the mass of 1 mole of that substance be? So in the case of carbon, you'd say the molar mass of carbon is 12.01 grams. Hydrogen, we'd say the molar mass of hydrogen is 1.008 grams. And for this molecule, CH4, also known as methane, we'd say the molar mass of methane is 16.042 grams. Okay? So molar mass is what the mass of 1 mole of that substance would be. Okay, pretty simple. make sure you know this term because you might see it. Okay, so now that we got this covered, let's look at this chart we have here. So we saw a similar chart like this at the end of this previous video, where we could convert between units when we were talking about atoms. We had atoms and we had and here instead of molecules or formula units. Okay, but here it's same thing. So if you want to convert from anywhere to anywhere here, these are the conversion factors. So if, for example, if you want to convert from grams to molecules or formula units, first you'd convert to moles using the periodic table, and then you'd convert to molecules or formula units using Avogadro's number. If you want to convert from moles to grams, you'd use the periodic table. You know, so this is a simple chart, just showing you how to get from one place to the other and what the conversion factors are. Okay. And I'll go ahead and use this chart when we do a few practice problems in order to help you guys out. Okay. So here's a few practice problems. So 45.5 grams of ammonia is how many moles of ammonia? Okay, let me go ahead and get a new slide here so we can go ahead and work this problem out. So the question was 45.5 grams of ammonia is how many moles of ammonia? So let's use, again, we're going to use dimensional analysis here just like we did in the previous video. So we're looking for, let me look here, moles of ammonia. Ammonia is NH3, by the way. And what we're given is 45.5 grams of ammonia. Okay. So it's equivalent to 45.5 ammonia. Okay. So what would we would do in a situation like this, where we had, let's say we're just talking about an atom, you know, like atoms, and we'd said, like, for example, let's say moles of nitrogen, and we're given a mass of nitrogen. What we do is we just look at the periodic table, and we'd say, okay, like, based on the average atomic mass, we know that 1 mole of that substance of nitrogen is going to have that mass, you know. If you don't know what I'm talking about, again, please watch a previous video. So here we're going to do the exact same thing, but we're going to say 1 mole of NH3 here is how many grams of NH3, but we're going to have to do a little bit extra work here to find out what is the molar mass of NH3. Alright, so what we're going to have to do is we're going to have to take nitrogen. So if you look at NH3, 1 mole of NH3, 1 mole of NH3 is technically 1 mole of nitrogen and then 3 moles of hydrogen. So we're going to have to find the mass of 1 mole of nitrogen and then add that to the mass of 3 moles of hydrogen to get the total molar mass of ammonia. So 1 mole of nitrogen, if you look here, I think it's 14.007. It's kind of hard to see here, but you can look at it in your periodic table. Okay, so 14.007 grams. And then 3 moles of hydrogen. The molar mass of hydrogen is 1.008. Molar mass of hydrogen is 1.008 grams. Okay, so 3 moles of that, we just multiply it by 3, and we would get 3.024 grams. And then we can just add them together. So if you add this to this, we would get 17.031 grams. Okay, so now we know that from here, this information what we've deduced is that 1 mole of NH3 has a mass of 17.031 grams. So we can just put that in here. And again, this is called the molar mass of ammonia, or NH3. So then, look, the units cancel out. Grams of NH3 cancels out grams of NH3. We multiply the top, we multiply the bottom in order to get our answer. So let's go ahead and do that. I have a calculator out here. So 45.5 times 1 divided by 17.031. And that's going to give us still getting used to this calculator. 45.5 divided by 17.031, and that's going to give us this number. Again, you have to count for significant digits. This number has 3 significant digits. This number has 5 So we're going to use a smaller number here, 3 significant digits. Answer needs to be rounded to 3 significant digits, so we round this to 2.67. So our final answer is going to be 2.67 moles of NH3. Okay, so it's exactly like what we did in this previous video, except that when we did this step here, we had to find the molar mass of ammonia using this process here. So it's just a little extra step, but it's really exactly the same thing. Okay, let's do another problem. Just add a new slide here. So the next problem says 12.1. I don't know why I kept doing this. This should actually be 1.21. So 1.21 times 10 to the 24th 4 millunits of sodium chloride has a mass of. Okay, so we're looking for the mass of the sodium chloride, so that's what we're looking for. So mass of sodium chloride, and we're given 1.21 times 10 to the 24th 4 millionths of sodium chloride. Okay, so that's what we're given. 1.21 times 10 to the 24th 4 millunits of sodium chloride. Okay. Oh, I didn't use the previous chart, the chart here for the first, but we can look here. So we're trying to get from, if you look here, we're trying to get from 4 millunits to grams. So what we're going to have to do is first convert to moles, and then, no. We're given 4 millunits, so if we're going to first have to convert 4 millunits to moles, and then convert that to grams. So 2 steps. So we know that 1.21 times 10 to the 24th 4 millunits of sodium chloride, 6.022 times 10 to the 23rd. I'm getting a little flustered here. 4 millunits of sodium chloride is equal to 1 mole of sodium chloride. Okay, just like how 6.022 times 10 to the 23rd atoms of an element is equal to 1 mole of the element, same concept here, 6.022 times 10 to the 23rd, 4 millunits or molecules of a compound is equal to 1 mole of that compound. Okay, so we're at moles, and then here, if you look here, we've gone from 4 millionths to moles, and then now from moles to grams, you're going to have to use the molar mass. So let me just make a separate column here. Ran out of room. Okay. So sodium chloride, again, separate this out. So 1 mole of sodium chloride can be thought of as 1 mole of sodium and then 1 mole of chlorine. So we can find the mass of each. So we know that 1 mole of sodium from the periodic table, if you look here, the average atomic mass of sodium is 22.990. Okay, so 1 mole of sodium is going to have a mass of 22.990 grams. Another way of saying this is the molar mass of sodium is 22.990 grams, once you get familiar with that term. And then 1 mole of chlorine, if you look here, chlorine has a molar mass of 35.453. The average atomic mass of chlorine is 35.453, so the molar mass of chlorine is 35.453 grams. Okay, and then we can go ahead and add these up. Let me use a calculator to do that. 22.990 plus 35.453. It's going to get 58.443. So 1 mole of sodium chloride has a mass of 58.443 grams. So we can use that as another conversion factor. So here we're going to put 1 mole of sodium chloride at the bottom in order to cancel it with the top here. 1 mole of sodium chloride has a mass of 58.443. Another way of saying that again is that the molar mass of sodium chloride is 58.443 grams. Same thing. Then our units are going to cancel out. Check this out. 4 millunits is going to cancel with 4 millunits of sodium chloride. moles of sodium chloride is going to cancel moles of sodium chloride. And then we multiply the top, multiply the bottom, and then divide. So let's first multiply the top here. Let me make this clearer. This is a 2. Okay. So first multiply the top, 1.21 times 10 to the 24th times 58.443. It's going to give us that number, and then divide that by 6.022 times 10 to the 23rd, and then that's going to give us this number here, 117.429, and on and on and on. And if you look at our significant digits here, this number has 3 significant digits, this number has 4, and this number has 5. So we're going to go with 3 and round our answer to just 117. So the answer here is going to be 117 grams. Okay, let's go ahead and do one more problem here. .4 grams of phosphorus pentachloride is how many molecules of phosphorus pentachloride? So let's look at this chart here. We're going to start with grams converted to moles, and then from there finally get to molecules. Okay, that's the strategy. So question again, let me look at this. We're looking for molecules of phosphorus pentachloride. So molecules of phosphorus pentachloride, that's PCl5, and we're given 36.4 grams of it. Okay. And so we're going to first have to convert to moles. If you look at our chart here, molecules to moles first. So we know, again, in order to look at the molar mass of phosphorus pentachloride, you can think of 1 mole of PCl5 as 1 mole of phosphorus and 5 moles of chlorine. So 1 mole of phosphorus has a mass of 30.97. Let me look here. I can zoom in here. I can't even see for myself. 30.974. Okay, so let me write that down here. .974 grams. 5 moles of chlorine. We just looked at this. The molar mass of chlorine is 35.453. Multiply this by 5, and we would get 6. Now, hopefully you have a calculator for this so you don't have to go through this brutal process. 2, 7, okay. So 177.265 grams. Okay, then we can finally add this together. I'm just going to go ahead and make sure I multiply this out first. 35.453 times 5. Okay, yeah, that's correct. And then we can add that to 30.974. And we're going to get a total mass of 208.239. So we know that the molar mass of phosphorus pentachloride is 208.239. So this is going to equal 208.239 grams. We're going to go ahead and put that here so we know, again, 1 mole of PCl5 has a molar mass of 208.239 grams. Okay, and then from here, we know just by the definition of a mole that 1 mole of PCl5 is equivalent to 6.022 times 10 to the 23rd molecules of PCl5. And then everything's going to nicely cancel out. Grams of PCl5 is going to cancel with grams of PCl5. Moles of PCl5 is going to cancel with moles of PCl5. And we're left with molecules of PCl5, and then we can go ahead and do the math here. So 36.4 times 6.022 times 10 to the 23rd divided by 208.239. Oh no, 208.239. Okay. It's going to give that here. I can convert this to, I figured out finally how to use this calculator to convert this to scientific notation, so that's this. So it's 1.05, this whole mass times 10 to the 23rd. And if you look here, we have 3 significant digits here, we have 6 here, and we have 4 here. So we're going to go with the lowest number 3. So our answer is going to be rounded down to 1.05 times 10 to the 23rd. And then molecules of PCl5. Okay, this video is starting to get a little long, so I'm going to go ahead and split it into 2 parts. This is a simple problems. In the next video, we're going to be also looking at the same thing, but we're going to actually do a little bit more complex problems. But that's it for now. Calculations using the mole is as simple as that.